What I'd do is spend maybe 15 minutes talking about the origin story of Echo and Alexa and the science challenges we ran into. It's applicable. She's 5 years old as of today. And then, open up to any questions you might have in and around what we're trying to do. I have a really unbelievably good job in that I get to see what you all are studying right now or teaching. What I was classically trained as a computer scientist is not what I do in my day job every day, and it is not the computer science we're using anymore, basically. It is, and it's super fun to watch this renaissance happening right now. And I start with that because I came into, when the idea was first put out there to build, the original idea for Echo and Alexa was to do a little thing that you could plug into the wall that would be able to understand voice. I came at it as probably the largest skeptic you could ever imagine. While I was at Apple, I had the pleasure to work with Kai-Fu Lee, Dr. Kai-Fu Lee, and he was a very advanced in speech back then. He had some of the earliest research back then on speaker independence. And we went so far as to build a Mac back in those days that had a dedicated DSP, and we did what I'd call probably a medium field microphone array that used that DSP and even had a wake word. Which is what we call Alexa's name, and that wake word was Casper. And I did a number of public demonstrations of that and never got through one demonstration without it failing completely. and just really bad. And it was an idea that was super ahead of its day. But you only have to have so many of those briefings in front of the press or pundits to never want to do speech demos again. And when it was postulated again that we were going to do something new, for me at least, it took a lot of convincing about what had changed since, and that was 10 years previously. And the things that led us to think that something like Echo and Alexa could happen. The first two foundational things Amazon had a pretty front row seat to. The first was computing in the cloud. This was, you have to go back not only 5 years from when we launched Alexa, but another 3 or 4 years ago when we were thinking up this idea. And back then AWS was doing very well, but we weren't really talking about it much publicly. But almost everything that we were doing inside of Amazon was now becoming cloud-based and elastic, where compute could ebb and flow depending on demand. And one of the exercise we gave to our teams as a leadership team was to people like yourselves was, okay, imagine a world in the not-so-distant future where compute is not a constraint. That what would you be able to do if you had infinite compute? And what would you do in a world like that? And so that was kind of part A. And then the second part that came up was that we, again, had a very good front row seat to was the rise of practical aspects of AI, machine learning, these advanced algorithms. It's not lost on me, they've been around for a long time, but they were because of larger amounts of data, because of larger amounts of compute, they were becoming much more realistic in their application. And this was also happening in 2011 and 12. And we were using early versions of these things, these algorithms, random forests, Bezier techniques, and things like that to drive our recommendation engine at Amazon. And we were seeing very early but very good response for when you would see something on Amazon back in those days, customers that bought this, that also bought that. When we were using these early techniques, we would see significant uplift in the applicability of that recommendation engine. And so that got also us together in a different meeting, but about the same time, where we said, well, we want to figure out a way that everywhere across Amazon, again, this is reasonably early, 2011, 12, how else could these algorithms be applicable? And we all took that as an exercise for the reader, went back to our separate corners. And one of the things that came together for us was when you put those two things together was, could speech solve new problems? And when we wrote down, the way we invent at Amazon is we use a process called the working backwards process. We don't use PowerPoint at Amazon. We write everything down in documents. So everything, my whole day is reading 6-page documents, and it feels like study hall. You spend the first 20 minutes of every meeting reading, and then you discuss and hopefully make a decision. Echo and Alexa started the same way. We wrote down this idea. And the idea was, well, if you didn't need all this, at the time, DSPs, or there wasn't even really affordable quad-core processors at the time, in the client, could you build a very low-cost client that did most of the computing up in the cloud? That was the compute side of the invention. And then the second part was, could we do enough machine learning such that we could solve the hard problems that were facing it for the use cases we thought. And our primary use case was to develop a thing that you talk to in your kitchen. And it turns out that the kitchen is an incredibly hard acoustics problem. But again, we had a lot of things going in our favor. And the first problem to solve is, in a noisy environment, well, the first, I'd say, computer science challenge we had to solve was, in a very noisy environment, from across a room, in an acoustically unfriendly place where you might put an echo in a corner with very reflective surfaces nearby, can we isolate the voice that is speaking enough that we can get a clear signal-to-noise ratio up in the cloud to be able to do ASR, automatic speech recognition, and then from there do a high probability of getting the NLU, or natural language understanding, right. And this hadn't been done before. The computer science of it and the physics of it had all been done before. What we do in our array microphones, and at the first one we over-engineered the number of microphones we had. We put 6 microphones around the edge and 1 in the center. But the techniques that we used were signal processing and beamforming, to basically try to isolate the speaker's voice from across the room. Those are techniques that are well understood, especially if any of you worked in defense. They are well used for a different part of the acoustic spectrum on the front end of a Trident submarine. Sonar uses the same kind of techniques to isolate noise. And what our teams had to do was obviously miniaturize that to a processor that didn't have near that many MIPS. And we used in the first Echo, we used a dedicated DSP for that. And we had to isolate it to mic arrays that weren't designed for that high fidelity. They're analog microphones, and that's hence the array. We could play a lot of interesting tricks. So that got the voice isolated. But the second hard problem on the client, which took probably most of the invention time, was getting the ability for this from across the room to wake up when we wanted Alexa to wake up. The first simplifier we could have chosen, and then decided not to, would have been to pick a wake word. Wake words are, for us, if you have a Google phone, it's Hey Google. If you have Siri, it's OK Siri, or Hey Siri. Sorry if I'm waking up your devices. And the easy way for us to go would have been to pick something like OK Amazon or Hey Amazon. What you're looking for in a wake word, and we did a lot of the early work on this, is you're looking for things that in the language you're choosing to launch. We launched with US English to start, at language and dialect that you're choosing to launch. You're looking for something that's not a common phonetic set of syllables or sounds that would happen to wake up. And so the longer it is, that can help. And then also the more hard consonants that you can have. It's unusual to have different types of hard consonants, especially in the US. So Ks are great because they have a hard K sound. X turns out to be okay. But we didn't want to do Hey Amazon or OK Amazon. Z's are pretty good because it didn't have any personality. And when we tested it with customers, people really, in their home, which is very different than how people necessarily feel about their phones, they resonated heavily with the idea that this would be a part of the family, that it would be personal. And sometimes getting started second, and we weren't the leader of getting a voice assistant out there, allows you to do something different. But the science to get the accuracy of that wake word correct was a much harder challenge than the teams thought when we went into it. And it's an interesting balance of balancing false positives and false negatives. False positives, if you were to say one of the phrases that was often in the early days, if you said, I like ice cream, that turns out the phonetic of I like X or ice is very close to Alexa. And we would get a false positive, and somebody would say, I like ice cream, the blue light would go on. She would respond, I don't understand what you mean about ice cream, certainly in the early days, and that would be a false positive. But at the same time, you don't want the false negatives where somebody actually does say Alexa and it doesn't wake up, because it's super frustrating. It'd be like me calling out your name and the third time you not answering, I start getting pissy. And so a lot of the effort in the early days of running that wake word algorithm locally, and that does run locally on the device. You can't do that in the cloud, or you'd be streaming content to the cloud all the time, and that would have violated our early privacy tenets. And so we spent a huge amount of time balancing those algorithms, and it's basically running a small machine learning inference engine locally that could understand the wake word and try to reject the things that didn't. In the original days, it was all done locally. Over time, we've been able to train it so we can also do some rejection in the cloud if we get a false positive, and just dump the utterance. So there's been a lot of work that happened on that. And then once at that point, we got to a point where we had a pretty good experience with the wake word. We got a very good signal to noise ratio that we could send up to the cloud. And then it was a real effort to understand how we could do our ASR and NLU work. And we started from scratch. We had no speech scientists at Amazon. So we had to hire a team from scratch. We did a couple small acquisitions. And like a lot of things, data matters in this. So for us, we had to find very creative ways that didn't violate customers' privacy to go collect data. So we had early versions of Echoes that we rented apartments all around the country. It turns out that the United States is not one dialect. If you've ever gone to Mississippi or the Bronx, you will know that. And so you have to put we collected data in 6 or 7 different regions around the US and trained the algorithm. And by the time we launched Echo 5 years ago, we had 1,000 Amazonians had an Echo in their house, and we had done all this data collection. But even with that, when we measured the customer satisfaction of the product, we knew it was just on the edge of acceptable. And back then, it's not too long ago, but you may forget, she knew how to do 13 things. Now she can do hundreds of thousands of things by counting the same metric. And so it's a pretty simple product, but still the accuracy was just good enough. So we launched it as an invite program and asked our earliest customers to come along with us and obviously share their data. Hopefully they had the opportunity from day one to delete it if they so chose, but those early customers didn't delete their data very often. They knew the product was getting better. And back then, we used mostly supervised learning techniques to tag our data, ground truth it, run it back through models. All the models are trained in the cloud. And then as the breadth of the product has expanded, one thing when you could do effectively 13 things pointing to which one is the likely one for the utterance was much simpler than now when she can do 100,000 plus things. So over time, we've also built a much more advanced, effectively, it's a little like a search engine in that it's a very good statistical classifier that can route where you think the right utterance is supposed to go. Often we might route that to 1 or 2 different places or 3 places in parallel, and then come back with a confidence score and hopefully respond accurately when we come back. So It's a long-winded way of telling you how we got part of the way here. But there's a lot of, one of the things that, that I walk away from as a case study, there's others that we've done that require this, is what you all are doing every day is unbelievably important to what Amazon and, by the way, lots of other tech firms are doing every day. There is not a place inside of Amazon right now that is not thinking about machine learning and how to use it. It's not only the golden age of computer science, you all have a lottery ticket. You have full employment. Whether you want to stay in academia or not, trust me, there is a time where it is a good time to be a computer scientist. And by the way, the things that we think we can solve with these techniques now are dramatically different than even what I thought 3 or 4 years ago. I'll give you another example where about 3 years ago, we announced a product as another kind of test out there called Echo Look, which uses depth cameras to, that you can take a picture of what you're wearing. And the mental model we had for that product was, well, if you could get 100 fashion designers at New York's Fashion Week, and they could tell you whether or not that style was in right now and good to go out for that occasion, then we should be able to train a machine learning algorithm to do exactly the same thing. And not too long ago, we were able to switch over. We had humans in the loop on this for a long time as the algorithm got better, but not too long ago, the algorithm got better than humans. So we could hire the best fashion experts in the world, and we have a better chance with a computer vision algorithm and the machine learning dynamics behind that. In this case, it used CNNs versus DNNs, but nevertheless, it's anything that you can find human beings are good at and can be trained and learned to know, even if they're experts. We're pretty convinced that algorithmically we can give it a pretty good shot at this point. So it's pretty exciting from our standpoint. Anyway, you had a couple questions, but I thought that'd be a good way to.
Okay, well we can open it up. I have one. I'll kick it off with one question.
Sure.
Which is something we studied in a class I taught in spring on virtual assistants. Why is Alexa and not Alex? There was a UN report that came out last year saying that not just Alexa, but other Siri and other virtual assistants were contributing to gender stereotyping. So I wonder if you could answer that, and then what is the fallout of that report, or what are you doing, or will I be able to go and talk to Alex?
Yeah. There were two things that informed it. One, which likely has confirmation bias. So you always have to know when your data could have some bias. The first was order of operations. We had so many resources, even though it might seem like you have infinite resources, and we are blessed with a lot of resources, we didn't have the chance at that time to model, because the personality has a lot of things that go into it. It's the text-to-speech voice, it's modeling the wake word, as I just said, so we'd have to model Alex, which is much even harder than Alexa, or whatever name we would pick, or Adam, or whatever it happened to be. And a new voice. We're better at voices now than we were then. So that's just time on task. So to get a product out, we had to pick one. And then the second thing was, then we tested it. And in testing it, I'm the first to always say that there could be confirmation bias, because that bias that you just mentioned is out there in society. But it wasn't even close. When we tested male voices and a male personality versus a female voice and a female personality for where we wanted to put a device, which was scattered throughout your home, customers of all age, sex, race, they all, again, I won't give the exact percentages, but it was incredibly swayed towards start with a female personification. That being said, because we had the chance of building personality into Alexa from day one, and she has a lot of personality, we then sort of said, okay, well, what kind of woman do we want her to portray? And we wanted her to be a strong, educated woman that has opinions on things that you would hope that she would have the right opinion on. So I think we're trying our best there. Now, all that said, over time, I think there will be multiple assistants. We launched one early. We haven't shipped it yet, but we announced it in the fall, where you'll be able to say, Alexa, ask Sam the weather, and Samuel L. Jackson will respond. We'll have a safe for work version and a not so safe for work version, and it's not safe for work. Trust me. It depends on where you work, but and that is, that's Samuel L. Jackson being Samuel L. Jackson. And he'll have expletives and his personality, and so I think over time we'll be able to give customers choice of the kinds, and it won't be one size fits all. It'll be like talking to a room like this. That there'll be some people experts will answer different types of questions, and those experts might have different voices and different personalities. Something we talk about a lot, though. Yeah.
Like back when Danny Hillis was making connection machines, I asked him, why do you do what you do? And he said, I want to make a computer that could be proud of me. And that really stayed with me. And it sounds like you're sort of invested in your product. I was just wondering if that resonates, and with a project like this, if you end up thinking about personality and humanity and consciousness and all that other stuff.
Yeah, I don't know if I go all the way to consciousness. You all see it firsthand. It's a long ways to that, I think, at least for the state of the art that I see. But it could happen someday. But we have a lot of work to do as an industry to get anywhere close to that. But we do think a lot about the impact, societal, and about when something becomes new like this, because it doesn't happen very often, and it's probably the thing when people ask, what am I most proud about the team? I'm most proud about this, is that, if I had gone back in time and I had done this in front of you all, your current self or your earlier self, and 5 years ago, the day before we launched, which is today or yesterday, and I said, okay, 5 years from now, there'll be 100 million things out there in homes and people's lives, well over 100 million, where the customer is interacting with this new computing paradigm, and they have no idea of the operating system that's in the device that they're talking to, and they have no sense of the app that they're running. You would have declared heresy on my behalf. You would have said that's you're talking nonsense here. That's crazy. But that's in fact what's happened. And it doesn't supplant your phone. Like, I love my phone. It doesn't supplant the computer that you're using over there. QWERTY keyboard was invented in the late 1800s and for mechanical reasons, and it's still serving a purpose today. But this idea, internally we call it ambient computing, that is a new paradigm. And so, and to get that right, we're learning every day. Back to the sort of soul of the question. Some of it is personality. I'll give you another example, which is, if you're going to talk to something, and increasingly talking to Alexa will become more and more conversational as the state of the art of sort of NLU gets better, and we get a better short-term memory and understand context better, anaphora better, and a lot of the techniques. One of the things we've given Alexa is she is opinionated. If you had asked her 2 weeks ago who was going to win the World Series, she ticked off a lot of Texans because she said Washington was going to win. By the way, that personality is programmatic. There's automation part of it, and some of it's editorial. But if you ever go to a dinner party devoid of opinions, it is the worst dinner party you will have ever been at. It is when you start talking about more interesting things and people have opinions, whether they're controversial opinions or not is a different thing. That conversation becomes interesting. And so as we define this idea of conversational AI and an ambient user interface that's in your home, which is a very private, different part of your life than on your go with your phone or even in your car, we're discovering that a lot of those things Danny said are coming true. You have to think about the interaction in a very different way. Kids are different than adults. People that are kind of more elderly are different, and so it's interesting.
Hi there, my name is Alistair. I'm a BBC journalist, but I'm on fellowship here with the Knight Fellowship.
Good fellowship. All right. Nice job.
And so I've got a question that I'd like you to answer it in the sort of the short term and the long term way, and that's the use of news in these kinds of devices. What do you see being possible quite soon, and what do you see as being a vision for how the delivery of news can be best optimized and balanced and not opinionated and various other things that many people want it to be?
Yeah, we started, we weren't sure, to be fair about that. And so we started with something we called flash briefing or daily briefing, which was basically news bites that we thought customers would snack on throughout the day. And very early on, we had a little customization when we launched it, but not much. But very early on, we found that customers did want to pick their news sources. That us trying to get in the way at all and editorializing that, we didn't do a lot of it, but we didn't have a lot of choice either. So in a world where you're not giving a lot of choice, you can be seen to be doing editorial, and we didn't want to do that. So the first thing that we did was give customers choice, and as you can imagine, much like if you were to get on the TV today, there are people that will be centrists, and there'll be people that lean left, and people that lean right, and some that want a mix of news. And we with that product, we've had an ability for people to kind of mix and match and get those sound bites. And that became incredibly popular. Like, it is one of the more, there's a few things that resonate really well with Echo and Alexa, but that feature is one that customers really do love, especially as they wake up in the morning and get home at night. The idea to get sort of a short, easy to digest version of the news, whatever version of the news you're so choose, is very interesting. That's not new either. Like, lots of your own company and CNN and NPR have all had their versions of the minute of news, and this kind of, in some ways, is a modern version of that, if you will. Now, more recently, as we've gotten more and more customers that have put devices with screens on them, be it a Fire TV in their living room or an Echo Show with a screen on it, video has become much more compelling for people, and the use cases have gotten broader. So, including light news is very popular for people getting short video clips, where, you know, it's just something. Sometimes we're getting bombarded so much with the heavy news of the day that something light and nice is interesting, God forbid. And then the other thing that we're also seeing is that customers, and even with that though, they want choice. So they want to be able to filter and pick their news sources, and we've continued forward with video. And then we're also seeing delight in when you append short news things to other types of things. So I'm for better or for worse, 1 year it was for better, I'm a diehard Cubs fan, have been all my life. I every day I ask the Cubs score during baseball season, and I think it was maybe a month and a half ago I did that, and the team had added a feature, which is at the end of that, it said, Alexa said, this box score, Cubs won 4-1 or whatever, you know, a little quick summary. Would you like to see a summary of the game? And they had a news feed of basically all the highlights of the game compressed down to kind of a minute and a half. It's a little bit like Red Zone for football, and it was delightful. So we see that kind of snacking. It's not meant, this kind of user interface, best we know now, is not meant for long-form viewing of much of anything, unless you're in the living room, and then it can be for TV. But it's great for snacking. Yeah.
Can you talk about potential applications in health and healthcare?
Yeah.
There's been a lot written about that, and how do you manage the privacy concerns associated with that, which probably exist anyway with Alexa, but with health data can even be more heightened?
Yeah, so the first thing we had to do was get HIPAA compliant, so that the data, the path on the data went to a repository that was deemed, you know, secure and critical. And so we're done with most of that work. There's a couple use cases that we're still working on that are there, and so that's just foundational privacy work. There's lots of foundational privacy work in every area. For kids, it's COPPA compliance. For, in Europe, you got to be GDPR compliant. California here, there's different, but that's kind of least common denominator. But then you think about what are the use cases, and because then we can route data to a place that we don't even see it, or we auto-delete it, depending on the API that the hospital or nursing home or wherever it happens to be. They can set that how they so choose. And the biggest, one of the biggest use cases, early use cases, is actually not the healthcare professional, but the patient. Turns out that patients are often, you can't get a remote control for entertainment. You can't. You're alone for long periods of time, so companionship turns out to be super important. You might be immobile in some different way, and so that is a very real and near-term use case that we see lots of people adapting. The second one, which is getting tested a couple places, is for hands-free use for the professional there too. So, again, I'm not going to opine about whether, there's just lots of bad germs in the world nowadays, and like less you touch in these environments, and so being able to do things hands-free is somewhat valuable if we can get the user experience right. Now, it turns out that in those places, the natural language problem is vertical but harder. Because you have to take into account a whole medical corpus in some cases. So there's a bunch of work that needs to be done there. But I think that's something in that area will be the second use case likely, which is just don't touch something while you're in near a patient, and be able to get data back, put something on a chart. That we still have to plumb through for the data and a few other things. But yeah.
Correct me if I'm wrong, but I think the most common voice-enabled device still by far is the smartphone. And I'm just curious, that's sort of an area where your primary rival and competitor Google Assistant sort of dominates. And Amazon, I think used to have a smartphone effort, but then they just discontinued it. Can you explain why Amazon decided to discontinue that effort, and do you have any plans in the future going forward to introduce a product like that, or maybe a watch or something?
Well, good thing I brought our roadmap up. So no, I'm not going to be able to answer the last part specifically. But so I think as it relates to a voice experience, I feel pretty good about our position. How people use voice on phones is very different than how they use it in the home. Best we can tell, we don't have a big phone business obviously anymore, and so. But the frequency of how people use voice assistants in the home is much larger, and give you a sense of it. We have billions of interactions per week on Alexa, so the scale of it it's at scale. So I don't think that's too much of an advantage. But why not a phone is a good question. We did one, and we differentiated it in a couple different ways. One thing I should start with is we don't, at Amazon, at least in my organization, I think Amazon in general, if we think something is well served for customers, and we can get our message out in the ways we so choose, then we're not going to build a device just to build a device. It makes no sense for us. So in general, phone business is very well served. You can get your Amazon app on it, you can get your Kindle app on it, you can get your Amazon Video app on it. We can give you access to the services we think that as a customer you might want. But we did have an idea for a phone we thought was differentiated, and we went at it in two different directions. One, we built a very advanced camera. May seem not so advanced as of today because cameras have come a long way in 5 years. But our camera, you could point it at almost anything and it would recognize what was around you. Now that didn't resonate 5 years ago. It's kind of new normal now, but back then it was just customers didn't love it. And then the second thing we did was we built 4 lower resolution sensors that could track your head movement. Basically very early versions of the unlock that you have on your phones if you have a recent phone right now. We didn't use it for unlock. We probably should have. That would have been a good idea. But we did it because we thought we bet that screen sizes weren't going to get very large, and we thought we could increase the perceived amount of real estate on a phone, and you could see more of a book, and you could see more of your apps and these kinds of things. Once again, that one didn't resonate with developers. They just didn't build apps for that. And the combination of the two meant that it didn't resonate with customers. So we just discontinued the effort and went on to other things. Whether we'll do another one in the future is a function of, do we come up with a good idea or not? You had a question there? Yeah.
I did have a question.
Yeah.
As technology like this becomes more conversational and more human, I'm wondering how we ensure that technology, those changes aren't to the detriment of the users. And I can think of specific populations, so people with dementia, people with autism, children, who might benefit from a more formal language that they need to use to activate these devices, or from an understanding that these devices aren't people. I'm wondering if you can address that.
Yeah, it's something we do debate a lot. I think there's there's probably more than that, but two issues I would take away from the question. There's first just an ethics question of, when we have data, are we using it right? Are we building this technology for good? Are we making sure that algorithmically it doesn't bias to bad? And those are mostly a function of organizational mechanisms and checks and balances. And there's some technology involved in that. We definitely alarm certain things that we want to make sure don't go the wrong way. And try to use Amazon as a leader to set, in some cases, legislation or regulation, and in other cases, use industry bodies to try to set what we think are the right ethics for AI. And knowing that as this evolves, we'll get a lot of stuff right, but we'll probably have to bob and weave on some stuff and adapt as we go through it. The second half, which we do spend more time on, is there a right way to talk to Alexa? And how do we make sure that you don't end up putting biases into the algorithms? And if you do, how do you make sure customers have choice around certain of those things? So I'll give you a couple examples of things we've built. We've built the beginnings of what we call polite mode, because some parents want to teach their kids to have an assistant answer only, or at least reward saying please and thank you. Now, that comes at a cost. If you want your child to say thank you, we have to leave the mic open a little bit longer. Not everybody wants that either for privacy reasons. Now, blue light would be on, but it means that it's going to the cloud for a little longer to make the conversation happen. We do that with something we call follow-up mode too. So we have an ability for somebody to turn on polite mode, as an example. And that teaches children to say please and thank you because they get rewarded. Alexa will say, thank you for saying that in such a nice way. Next time, would you say please? Or say the magic word, things like that. And that's an example of that. Another one is bias is about, I won't have the data right, but millions of households, tens of millions around the world, probably hundreds of millions around the world, but certainly tens of millions in the US, are multilingual. And so we had a huge bias that Alexa only understood English in the US. We had Spanish model. You can go to Spain right now and turn on Spanish. In Mexico, you can turn on Spanish. But we bias, if you were speaking with a heavy Spanish accent, or what mostly happens in bilingual households is you get some mashup of the language. Either two people are talking in the separate language, or more likely it's interspersed. A proper noun will be Spanish, and a verb will be English, and then something else might be a combination thereof. This happens in India too, with Hindi and Indian English. And so we've just started rolling out, and so we saw that, and we started training for that basically in the data, and we started rolling out dual language support for exactly that reason, to try to get away from the bias that, it's just one. And you can imagine taking that to some of the examples you gave, which is kids speak very differently than adults. And do you want to reward, not reward a lisp? Well, it's hard. That's more an ethics thing. You start thinking about that. Boy, you'd love somebody to talk. And parents try to correct, but they don't correct in bad ways, a good parent. And so there's all sorts of interesting issues. But I gave you 2 examples of how we're thinking about it. Yeah, here. Okay, yeah.
2 questions. One is regarding innovation. Like when I first saw Alexa, I was like, I'm not gonna buy this. It's stupid, because I thought the phone had Siri, and and I thought that's just like using that tech. Tech wasn't new, but the way Amazon made it, I think, and a lot of people bought it, and I was surprised, like, why are so many people buying this thing? It's nothing innovative, but then I bought it, and I tried to build an app for it, and then I realized, like, I wasn't using it for anything, music, news, weather, and that's it.
Mm-hmm.
So 2 questions. One is, like, how do you guys think of innovation when you look at technology? Like, I noticed it was packaged in this way and people bought it. You could have asked the same things on your phone or something. Second question is, where do you see, like, the apps? Because there are a lot of apps there, skills for Alexa, but I've heard that most people are not using many apps, and we talk about people who make money from skills, it's very few.
Yeah. 2 very different questions. So the first one, our invention process at Amazon is the same if it's a new AWS service as if it's a new device or service or a new feature on the retail website. And basically, we write down going back to media, we write a 6-page memo. The first page of that is we write the press release as if we were launching the product that day, even though nobody's written a line of code yet. And then we put 5 more pages in that document of questions that a normal person would ask about this. How much would you price this? What invention do you have to do to make this happen? How many people do you think you'd need to build this? Things like that to try to get your head around what this would take. And we call that the working backwards process because it works backwards from the customer. What are you actually going to deliver to the customer? And then we iterate on that document. Before we ever greenlight anything, we may rev that document 10 times, 20 times. And then we may cancel. We may never put a resource on it. But the goal is to get that document super crisp so that we believe it's a differentiated product. And then you hand it off to a group of engineers and you say, go build it. And they should be able to take that doc. They'll have to build more specs, but they should be able to take that doc and start coding or start throwing gates if it's a silicon project or whatever it happens to be. And that, we think, is a way that allows us to be very aligned on the innovation. Once we green light something, sans new data that might come in, we're convicted that we're going to deliver that. We're going to invent that. We're going to make that happen. Again, new data might come in. We might have to change things on the edges. Sometimes you do cancel stuff because it's not viable anymore or the invention didn't come to fruition. But the key is to have conviction. And we had, as Echo as the question was, we had conviction around Echo. We thought it was sufficiently different than what's on your phone. It worked from across the room. It was always powered on. It never ran out of battery. It worked in noisy environments. It had personality where phones didn't really have personality. Now they're adding it now, but this is, you gotta remember, this is 7 or 8 years ago. We had conviction of these types of things. Could it have failed like the phone? Sure, absolutely. But that'd be okay. That's what experimenting is for. That's what if every invention was a success, they wouldn't be inventions, they'd be proofs. So the key is if you're going to invent, just like the scientific method, you have to be willing to fail. And sometimes those will be very public failures in the case of the phone, but that's okay because the successes, if you have big successes, way compensate for the failures that you may have. The second question on skills are basically cloud-based enablements of natural language apps, if you want to think of them that way. And they're very easy to write, so much so that I've written a couple. And if I can write them, trust me, anybody can. And in the early days, it was a little like an app store because that we wanted to get out. It was a huge, by the way, scientific breakthrough. Often those happen in academia. In this case, it happened at Amazon. To make it, people thought the idea of skills were impossible. That without a large corpus of data to train an NLU model, could you build an app for voice? Nobody had figured that out before, and we came with a couple breakthroughs that made that happen. But to get it out quickly, we made some trade-offs. For example, you had to enable them as a customer, like an app store. You had to invoke them by name, so you'd have to say, Alexa, ask to play Jeopardy, you know. But that's not the way things happen in conversation. If I was going to ask for, you know, a question about the intersection of media and computer science, and I just put it out there, you're going to answer. You're the expert. I wouldn't have to call you by name or maybe even look at you. You just would answer. If I was asking a question about recruiting at Amazon, one of the two helpful people from my recruiting team here would answer without being asked. And that's how conversation happens. So with skills, we have now gotten much closer to that. So there's over 100,000 skills, but for thousands of them, you don't have to ask the name anymore. You don't have to go say, Alexa, order a car or ask Uber to order a car. You just say, Alexa, order a car. If you're using Uber every time, we'll go automatically there. If you've never done it before, we'll get the two most popular and say, would you prefer Lyft or Uber? And that automatically happens. Now, that was just advancement in science and our way of orchestrating and things like that. And so as that's happened, usage has gone up dramatically. So I would, now, are people monetizing billions of dollars yet? No, not yet. But people are monetizing. We have lots of people that are making a living off doing skills. And certain kind of skills, like smart home skills, there are billions of dollars of revenue flowing through smart home skills. So in terms of people using like things like smart home music, same thing. Billions of dollars worth of music now being listened to that wasn't before because of Alexa. So there's a business here somewhere. We'll figure it out. Yeah.
Hi, my name is Cheryl Phillips. I teach data journalism.
Why?
And I wanted to circle back to the news question from earlier. And I know a lot of the news sources, if you say, Alexa, give me the news, it's all very much national sources. So I was, presumably, if you're a Cubs fan, you might want to hear what Paul Sullivan has to say.
Yeah.
Group writer, baseball writer. So what are the plans for integrating local news sources?
Yeah, it's a good question. That's more order of operations. I think we'd love to get it down to a more granular level. Today, the way to get there a little better is ask for a specific podcast. It doesn't go through the news flow as well, because, again, there's some question of what is a news podcast, which isn't, but you can get to most of the podcasts. You can also always ask for a local radio station. So if you have a local, KCBS or your favorite thing that you might listen to, those all can be invoked by name as well. So that's the way we've kind of thread that needle a little bit. But it's not for lack of wanting the feature that you're talking about. Over time, we'd love more granularity. It's, even with the amount of resources we have, and we're, as I said, blessed with them, we still seem to always have more ideas than we have people to type code, that is. I think one more probably, yeah. Yeah.
Great.
Sorry.
Yeah, I was part of the Invite program 5 years ago, so I got my Echo and it was awful, and then it got better and better, right? Recently I got an Echo Dot, and it seems to be just worse than my original Echo, but smaller and cheaper. Is there hardware innovation on the horizon that'll ever make me think that I should buy a new speech platform, barring screens or what have you?
Yeah, all the data I would have would suggest that you are an anomaly, but anecdotes mean things. So if you can send me your customer ID, and I'll find out why your dot is not performing well, if you give us permission to do so. Because it's, all the data would say, like I would just say, in the last half year, our NLU performance is up relative, tens of percentage points, which is miraculous, by the way. Our wake word performance is up 50% in terms of accuracy. So now I'm using averages, and your anecdote is real. So, but in terms of hardware breakthroughs, I think the thing that we can do more of as we get more MIPS locally that are effectively free MIPS, because we are talking about delivering a dot for $22 on Prime Day. But there's still a huge amount of MIPS, like the least, it's nothing like the processors that's in your phone, but what was in your phone 4 years ago is in an Echo Dot. basically, or 5 years ago, 4 years ago probably. And so there is a lot of processing power in there. And so what we can do is do certain things more locally to increase accuracy and performance. So for example, we've moved to many of our devices now smart home commands that you want to be very fast, turn on and off lights that don't have to go through the cloud mesh but can go directly to a Wi-Fi enabled light or a Bluetooth enabled light. We now run that ASR locally. And so we can get the latency for turning on and off a light not to be 2.5 seconds, but a second, which it doesn't seem like a lot until you see it. And then you're like, oh yeah, that's a real, so things like that we can do a lot of. We can do things with security better to understand who's talking so that we can have better speaker recognition. That can be done locally. We can detect sounds locally. We have a feature under Alexa Guard where if you put it in guard mode when you leave, we detect for sounds like broken glass, carbon monoxide detectors, smoke detectors, and if those go off, we send a notification to your phone and tell you that something's wrong at the house.
All running locally.
All runs local. Yeah, none of that hits the cloud. Yeah. All right. Well, thank you for the time. Appreciate it. It's awesome. Yeah.